Hi students, today we're going to learn about the powers of 10 and how we can use them to write really small or really large numbers. So let's start with our definition. Powers of 10 may be used when working with very small or very large numbers. The difference between the small and large numbers is going to be in the exponent. When the exponent is positive, the number will be greater than 1. When the exponent is negative, the number will actually be between 0 and 1. So to truly understand this, let's look at an example. The one down here, we have the base, which is always going to be 10 because we're learning about powers of 10. And then over here we have the exponent, and that's what's going to change. So let's say we have 10 to the second power. 10 to the second power, that's a positive exponent. If we simplify that, it's 10 times 10 because we have 2, which means we multiply the base times itself twice. That's going to be equal to 100. So you can see with that positive exponent, we've proven that it will be greater than 1. Now if we have a negative exponent, say 10 to the negative second power, with negative exponents, the number's not going to be negative, but instead of multiplying by 10, you're dividing by 10 each time. So we would have, in this case, 1 divided by 10, or 1/10, times 1/10, and then this time we get a solution of 1/100th, and 1/100th is a number that is between 0 and 1. So on the next slide, we're going to look at a chart, and we're going to see if we can look at some patterns as we look at the different forms of powers of 10. At any time, I would hope that you guys have some sort of writing tools. You can use your dry erase board or pencil paper or anything that you have so that you can practice this along with the video. So the first one here, we have power of 10. The power of 10 here is 10 to the second power. And just like we saw in the last slide, the expanded form for 10 to the second power, if we expand it and we make it bigger, it's going to be 10 times 10. The fraction for this, because it's not even a fraction as it is, but if we want to write it as a fraction, we would simplify 10 times 10, which is 100, and we would put the number 1 on the bottom. So for any whole numbers, if you're asked to write them as a fraction, we have 100 ones, 100 wholes, so the whole is represented by the 1 on the bottom. In standard form, this would just be 100. 10 to the first power, if we want to expand it into a multiplication problem, we could say that's the same as 10 times 1. 10 times 1 as a fraction, 10 times 1 is 10. Again, it's a whole number and we're being asked to write it as a fraction, so we have 10 wholes, which is 10 over 1. And then, of course, our standard form would be 10. Now that brings us to 10 to the power of 0. 10 to the power of 0, common mistake, I'll show you over here. 10 to the power of 0 is not 0. Okay, remember the exponent tells us the number of times we're multiplying a number times itself. We still have the number 10, and we're not multiplying it by 0. Instead, 10 to the 0 power is 10 divided by 10. So that would be the same as 1, which the fraction would be 1 over 1, and then the decimal and standard form would simply be 1. The best way to see this is to look at the pattern that we have here. We have 100, when I go from 100 to 10, our exponent is getting smaller. I'm dividing by 10. And when I go from 10 to follow that pattern to the next exponent that goes from 1 to 0, it's going to get smaller again by dividing by 10. So that brings us to our next number, 10 to the negative 1 power. 10 to the negative 1 power would be 1 over 10 to the first power. Because instead of multiplying by 10, we're taking 1 and dividing it by 10 one time. So the fraction for this would be 1 over 10. Okay, it's not a negative number. It just means that we've moved the decimal point over one more place to the left. So if we look at our examples up here, I can show you. So here, our decimal point is there after the 100. We have a decimal point after 10. Then we have a decimal point after 1. Each time you can see that the decimal is moving one place to the left. So then for 1/10, it's going to be 0.1. We've moved that decimal point one more place to the left. Now let's look at 10 to the negative second power. The expanded form would be 1 over 10 to the second power. It's like the inverse, or it is the inverse of 10 to the second power. We know that 10 to the second power is 100. So we're going to take that as we explore 10 to the negative second power. The expanded form would simply be 1/10 times 1/10, which our fraction for this is going to be 1 over 100, and then our decimal is going to be 0.01. And you notice that our decimal point from the one before moved over one more place to the left, because each time our exponents get smaller, we're going to divide by 10. Now we have 10 to the negative third power. Okay, our expanded form for this would be 1 over 10 to the third power. Okay, so 10 to the positive third power would be 10 times 10 times 10. 10 to the negative third power is going to be 1/10 times 1/10 times 1/10. So we have the three tens, but it's in the form of a fraction, 1/10 times 1/10 times 1/10, which simplifies to 1/1000th. And then we move our decimal place one place, or we're dividing by 10 again. We're moving our decimal one more place to the left, which would be 0.001, which is 1,000th. So the last one, 10 to the negative fourth, we follow the same pattern in the chart, would be the same thing as 1 divided by 10 to the fourth power, because it's the inverse. So because of that 4, the expanded form, the second type of expanded form, is going to be 1/10 times itself 4 times. The fractional value I could get by multiplying those tens by themselves 4 times on the bottom, which is going to be 10,000. And then 1 times 1 times 1 times 1 is 1. So again, none of these numbers are less than 0, but they're very small decimals. So 1 to the 10,000th power is 0.0001. Notice how all of the numbers we wrote down are positive. They're all positive numbers. The negative exponent does not cause these numbers to be negative. It just causes them to be really small. And also you should notice that the numbers in the last two columns, these numbers in the last two columns here, if we look at these last two columns, the only digits that you should see here are the digits 0 and the digits 1. The exponents do not show up in that last column. Even though this is 10 to the second power, you don't see any 2's over here. Even though this is 10 to the negative third power, you don't see any 3's over here. The next thing we're going to do is we're going to look at how we can use Desmos, our Desmos calculator, to calculate powers of 10 and also to check our answers. So what I'd like you to do is to pause the video and pull up your Desmos calculator. All right, hopefully now you have your Desmos calculator ready. I have my calculator right here. I've just pulled it into my screen. I'm just going to pull it up here. Now, if you notice on the dry erase board, I have some examples. And those are examples are shown here in the text on your notes, how you would convert or how you would practice. So let's look first at what we have here in the print. It says Desmos, our wonderful Desmos calculators. We can use them to check powers of 10. So I'd like you to try to convert them, but once you convert them, you can then type in the numbers as an exponent, a fraction, or an expanded form. And you can double check to see if it matches a different form. And your teacher will be telling you more about this feature as you guys practice. Okay, so these buttons here are really important. You have the A to the B button. That's what we're going to use for entering in our exponents. The other button that's really important here on your Desmos calculator is the A over B. That's our fraction key. And then over here, you can see that we've used our fraction key and we've put a number that's an expanded form to see what its decimal form would be. Now that probably seems a little confusing right now, but it'll make more sense once we practice it. So here I have the numbers, and we're going to practice looking at how we can change them to different forms with a calculator, because this is a calculator skill. So I'm going to pull up my calculator, and I hope you have yours too. And I'm pull it over here. And I'm going to practice taking these numbers and looking at the forms by using the calculator. So first I'm going to start with 10 to the negative second power. So I'm going to type in 10, do this along with me. And if I want to represent that negative second power, I'm going to click on this A to the B button. And notice that the cursor kind of moved up a little bit. And now I'm going to put in negative 2. Negative 2 is entered by taking the minus sign or the subtraction sign and putting a 2. Notice what just happened. As soon as I finished entering in 10 to the negative 2, I have the decimal value over here. So let's say you have a multiple choice question and it's asking you for the decimal for 10 to the negative second power. You could type it in to see what its decimal form is. Let's try 1/100th. What if it's given as a fraction? If it's given as a fraction, I click the A over B key. Okay, let's try that again. You're going to click the A over B, and you notice now you have the bar and you have the cursor blinking, and you can also move the cursor down here for fractions. A very helpful tool. So I'm going to put the 1 on top. I'm going to move my cursor down below the bar, the fraction bar, and I'm going to put 100. Voila! We have 0.01. You have the decimal there. So now we verified that 1/100th is equivalent to 0.01. So far we did 10 to the negative second power, and we saw that that was equivalent by using our calculator to 0.01 or 1/100th. If we put in 1 over 100 to get the decimal, we use that fraction key, and we also get the decimal of 0.01. And now let's look at that last one, 1/10 times 1/10. I'm going to clear this, and I'm going to use my fraction key again. My cursor is blinking, so I'm going to put 1 on the bottom. I have to click there, over 10. Now, before you continue with the times 1/10, you have to actually click away from the fraction. If you don't, I'll show you. If you stay there and you try to put that 10, it actually puts it with the other denominator. So what you need to do is click over here so that you can get the multiplication sign outside of the fraction. So times, and then I'm going to have 1 over 10 here. And you can see that I get that same decimal again. Another way, I get 0.001. Or excuse me, 0.01. They're all equal to 1/100th. I'm going to show you another thing that you can use. What if we know the decimal, but we want to use the Desmos calculator? If we have a really small decimal, Desmos calculator will calculate for us the power of 10. Let me give you an example. If I have this decimal, 0.0001, and I want to know the power of 10, Desmos will calculate that for us. I do want to note that when you have really small numbers like 1/100th, Desmos will not necessarily give you the exponent, but for some of these tougher ones, you can try using your Desmos calculator. I'm going to show you how to do that. So if I pull up my calculator, and what I'm going to do is I'm going to put this number in, 0.0001. Now notice, there's no solution here. But watch what happens when I multiply it by 1. When I multiply it by 1, it tells us I have 1 times 10 to the negative 4. So what it's doing is it's converting this number, 0.001, to its power of 10 with the exponent. So we can determine that 0.0001 is equal to 10 to the negative 4th power. Now I do want to show you, like I said, that if we make this number smaller, 0.01 times 1, it doesn't necessarily give you that exponent. If I try it with 0.001, it doesn't. But notice, as I put more zeros between the decimal point and the 1, our exponent is changing. It will convert it for us. So what does that tell us? The smaller ones we probably need to be able to memorize how to do them, moving the decimal point. But for some of the, bigger numbers, the smaller numbers with those higher numbers for the exponent, or higher negative numbers for the exponent, Desmos can be a useful feature. Let's try one more with that. So what if my number was 0.000001? That's a lot of zeros. Okay, I know it's going to be a power of 10, so I'm going to take my calculator and I'm going to put it in. 0 point, and I think that's 5 zeros. 1, 2, 3, 4, 5. I have my 1 at the end. Now again, if you get to this part and you don't see a solution, you've got to give it an operation. You got to tell the calculator that you're doing something. So it's the same thing, right? The number stays the same. It's just a different format. I'm going to multiply, or form. I'm going to multiply this by 1. There it is. So this gives us the power of 10. You don't need this 1 because it's just telling you you have one group of 10 to the negative 6. So this is what we're looking for here. So now I can go back and I'm going to put in this number is equal to 10 to the negative 6th power. Okay, now you're going to have some practice with powers of 10 using the chart and using your Desmos.